Hey all, so today as we promised earlier, we are going to discuss about some of the problems on chapter 1 of NCERT, which is units and measurement. So let us start with it. चलिए बात करते हैं हम एक पहली प्रॉब्लम पे जहाँ पे हम सिग्निफिकेंट डिजिट्स को फाइंड आउट करेंगे. So here is the problem is stated right here. So it says that state the number of significant digits in the following. राइट तो हाउ वी कैन कैलकुलेट इट, हम कैसे कैलकुलेट कर सकते हैं ये हम देखेंगे बारी बारी से एक एक करके. राइट तो चलिए स्टार्ट करते हैं. लेट अस स्टार्ट. तो सॉल्यूशन इज देयर. राइट नाउ इन द वेरी फर्स्ट प्रॉब्लम which is right here, so it says that what is the significant digit we have in this number or this measurement, which basically it's some measurement m square, which represents area obviously. So it is 0.007 meter square. Now remember that we have already stated in our previous videos where we were discussing about the rules for finding the significant digits, जहाँ पे हम ये बात कर रहे थे कि significant digits को हम कैसे find out करें. वहाँ पे हम लोगों ने state किया हुआ था, we talked about that zeros which lies on the right side or sorry left side of the significant digit are insignificant. जो भी zeros लेफ्ट साइड में पढ़ते हैं सिग्निफिकेंट डिजिट के, उनका कोई सिग्निफिकेंस नहीं होता, दे आर इनसिग्निफिकेंट. और ये हम कैसे डिटरमाइन करेंगे, हाउ वी कैन डिटरमाइन इट. सो लेट अस टेक 0.007. नाउ चेंज इट्स यूनिट इनटू सेंटीमीटर स्क्वायर. व्हेन यू चेंज इनटू सेंटीमीटर स्क्वायर यू विल सिंपली राइट 0.007 मीटर स्क्वायर सॉरी इनटू 10 to the power 4 centimeter square, which is nothing but 0.7 into 10 to the power 2 centimeter square, or basically you can write it 70 centimeter square. So what you will see, the one is significant digit we have is 7. 0 has no role here, you can remove it anytime, and 10 to the power powers do not count in measurement, basically in significant digits. So only significant digit we have is 7. So the answer will be 7. So हमारा आंसर जो है वो 7 है. ओनली वन सिग्निफिकेंट डिजिट हमारे पास केवल एक इस प्रश्न में सिर्फ एक ही सिग्निफिकेंट डिजिट है. वन सिग्निफिकेंट डिजिट. चलिए हम दूसरे पे जाते हैं, दूसरे नंबर पे, और यहाँ पे सिग्निफिकेंट डिजिट को कैलकुलेट करते हैं. वी आर गोइंग टू सेकेंड वन एंड वी विल ट्राई टू कैलकुलेट दिस सिग्निफिकेंट डिजिट हियर. 2.64 into 10 to the power 24 kg, right? So here number of, it is straightforward, here number of significant digits are these three. Here it was only one, right? 2, 6, 4. They are all significant. So number of significant digits is simple rule. In this case will be 3. Right? This is the answer. Now let us go to the थर्ड वन, तीसरे वाले के बारे में बात करते हैं. तो 0.2370 ग्राम पर सेंटीमीटर क्यूब, विच लुक्स लाइक अ डेंसिटी, राइट, बिकॉज इट इज ग्राम पर क्यूब इज यूनिट ऑफ डेंसिटी. सो 0.2370 ग्राम पर सेंटीमीटर क्यूब, राइट. So 2370. Now you can look at it carefully. 0 is on the left side of a decimal, or obviously the significant digits have no significance because they can be always replaced using this change of dimension or change of unit, right? But 0 on the right side of the significant digits are always significant. Remember that, because it may happen that at one time you are measuring using this scale, you have a variation on this unit also, right? So that's why this unit is significant. You may in the next measurement you will have 2 3 7 2 or like that, or 4 or like anything can happen, कुछ भी हो सकता है. तो उस केस में जो है when हम जब अलग अलग बार मेजरमेंट करते हैं तो हर बार जो है कि it may be due to human error, due to the instrumental error, or any sort of error. So what you will observe that this large digit may bring some measurement. So this is uncertain, and that's why it is significant. We have already stated that significant digits have two parts. One is certain and another is uncertain one. So this 0 can be considered an uncertain one, and that's why it is significant, right? So ये significant है, तो इसमें significant digits कितनी हो गई? How many are there? 4. So number of significant digits here are 4. Right? चलिए अब चौथे, पांचवें, छठे यानी 4th, 5th और 6th की बात करते हैं. We will talk about 4th, 5th and 6th measurement. So let us take the 4th one. 4th को लेते हैं 6.320. The same rule. It is very straightforward. So how many significant digits are there? 6320. All are significant, right? Just using the same rule which I discussed just before in third one. उसी रूल को हम फॉलो करेंगे जिसको हमने अभी तीसरे वाले में किया है, और उसी से हम ये लिख देंगे 4 significant digits हैं. There are 4 significant digits. So the answer is 4 significant digits, right? Right? Now let us go to the 5th one. पांचवें पे जाते हैं. Here also now this is also straightforward, as we have already told you. हमने already इसके बारे में बात की है. Just go to the earlier videos and just try to look into the rules. You will find that the zeros between the significant digits are always significant. जो वो जीरो, वो शून्य जो कि सिग्निफिकेंट डिजिट्स के बीच में लाई करता है, वो हमेशा सिग्निफिकेंट होता है. ये रूल हमेशा याद रखिए आप. सो वी हैव ऑलरेडी डिस्कस सम ऑफ द रूल यूजिंग बाय दीज एग्जांपल्स. सो आप यू कैन ऑलवेज रिकॉल देम. यू कैन. सो दिस इज द वे ऑफ स्टडिंग. you just read the problem or tackling the problem, read the problem, then you go to the concepts again, read them, then again come and try to solve the problem. If you don't understand, then again go to the rules, again reread them, then again come. That is how you solve it. We call it try and try. So when you try again, you understand it better. आप जब बार बार उसी चीज़ को पढ़ते हैं तो हर बार कुछ नया निकल के आता है. You always understand, come up with something new, and it makes things more clear. चीज़ें ज़्यादा स्पष्ट होती हैं. आप जितना समय बिताते हो एक ही चीज़ पे जब बार बार, तो चीज़ें ज़्यादा समझ में आने लगती हैं. सो दैट इज़ वाई आई एम टेलिंग यू टू गो अगेन एंड अगेन, रीड देम टू मेक इट मोर क्लियर. आप बार बार जाइए और देखिए कि क्या क्या रूल्स हैं. And this when you will solve these problems, you do not need to remember the rules always. So let us talk about this 5th number, 6.032 Newton per meter square. So as we already discussed about it, so there are 4 significant digits. सो जैसा हमने पहले बात किया है इसके बारे में, यहाँ पे 4 सिग्निफिकेंट डिजिट्स हैं, राइट। नाउ लेट अस गो टू द 6th one. Now 6th one is quite straight forward. ये काफ़ी आसान है अगर आप इसे ध्यान से देखें तो। So यहाँ पे how many are there? So these digits are not significant, as we have already, according to the rule we have discussed in earlier videos, right? So these digits are not significant, as they can always be removed by just changing the power, by changing the unit, right? So significant are these 4. So how many significant digits are here? Again just like others, 4. So यहाँ भी उतनी ही significant digits है जितना ऊपर थी, 4 significant digits, right? So this is one exercise in the significant digits. I hope that I means my attempt to make it clear has been fruitful. जो मैंने प्रयास किया है वो आपको समझ में आया होगा और आप इससे जो है और सारी एक्सरसाइज और एग्जांपल्स को सॉल्व कर पाएंगे. सो आई विल सजेस्ट यू टू गो एंड रीड अगेन द रूल्स एंड देन अगेन कम टू द प्रॉब्लम एंड ट्राई टू सॉल्व देम. सो इट इज़ जस्ट ए वे ऑफ सॉल्विंग द प्रॉब्लम्स. reading the problem, then again going to the rules, reread the rules, and then come back to the problem again, and then again. So it is just this process just goes on. It makes you better understand the basically the concepts. Now significant digits, why we are stressing so much on it? हम इतनी बात क्यों कर रहे हैं इस पे? क्योंकि जब भी हम मेजरमेंट लेते हैं, in particular when you perform certain experiment and wherever the humans and machines are involved, there are always errors, right? So that's why these digits are important, which decides up to which digit you have to take the reading, right? So like you are doing any experiment in your school which is related to the oscillator, simple harmonic oscillator is there, or any other experiment like that. So wherever you perform certain measurements, significant digits are always important. Least counts of the instrument is important. So you must be careful with that. And this is also the very fundamental of the physics. ये बहुत ही basic है, शुरुआती चीज़ है एकदम. So unit and dimension and significant measurement and significant digits. So इसकी proper understanding आपको आवश्यक है. It is very much necessary to understand it very clearly. Then only you can go to the advanced topics. And also I think there must be something into the in the exam also, like in JEE and NEET and other exams. वहाँ पे भी question बनते ही हैं. They always come. So if you have fundamental understanding, these problems are easily solvable, and you scoring also. So just prepare it very carefully, and also just by reading the rules and solving the problems, right? So let us start with another beautiful problem from NCERT. चलिए हम बात करते हैं इस प्रॉब्लम पे. So what does the problem says? So a famous relation in physics relates moving mass m to the rest mass m naught of a particle in terms of its speed v and the speed of light c, right? So a boy recalls the relation almost correctly but forgets where to put the constant c. He writes m equals to m naught divided by root 1 minus v square. Now guess where to put the missing c. Now अब the problem ये कह रहा है कि एक फेमस रिलेशन है जो कि मूविंग मास m को रेस्ट मास m नॉट से रिलेट करता है, और जिसमें v जो पार्टिकल का स्पीड है और जो c जो है वो स्पीड ऑफ लाइट है। तो एक लड़का है जो कि इस रिलेशन को रिकॉल करता है, ही इज ट्राइंग टू राइट इट, बट द प्रॉब्लम इज दैट ही मिसेस सम ऑफ द टर्म्स like C. Now it is asked that if the relation he writes is following, then put the C at correct place or put the C or put the missing C, right? So ये क्वेश्चन है कि C को सही जगह पे आप रखिए। तो हम अगर इस प्रॉब्लम को ध्यान से देखें, if you see it very carefully, so what we'll observe that it must be, as we said earlier, the first thing for to verify whether a formula or relation is correct is using the dimensional analysis, right? So here now let us check the dimension using the dimensional analysis. Now this relation let us check on the left side, and LHS says that a small m, which is a moving mass, has a dimension of capital M. It is simple, right? LHS equals to dimension is capital M, and RHS is what? This capital M divided by root of 1 minus, now what is V square? V is nothing but LT to the power minus 1 square, right? Now if you understand what we have discussed earlier in the dimensional analysis, अगर आप इस बात को समझ रहे हैं कि dimensional analysis में क्या डिस्कस किया गया है, तो आप ये समझ रहे होंगे कि you would have been understanding कि we cannot add or subtract quantities of different dimensions, right? तो हम डिनोमिनेटर में अगर केयरफुली देखें तो यहाँ पे डिनोमिनेटर में जो क्वांटिटीज हैं, एक जो है स्केलर है, वन इज स्केलर, इट हैज नो डायमेंशन, whereas v square has a dimension which is lt to the power minus 1 whole square or l square t to the power minus 2. What does it mean? Now this, if you want this formula to be correct, then you have to put something in the denominator of this velocity term which is just equal to this term, right, in dimension, so that they both cancel out and it becomes scalar. Now scalar and scalar can be added or subtracted. Is it okay? ये आपको समझ में आ गई बात? तो यहाँ पे हमें क्या रखना है कि सेम डायमेंशन की कोई क्वांटिटी डालनी है। Now what is this dimension of c? C is nothing but the velocity of light, speed of light, right? So speed of light is there, so it has dimensions same as of v. So you just put it here to make it dimensionally correct. So if you put c, what you will get, m divided by root 1 minus l to the power minus 1 divided by l to the power minus 1 whole square, giving you m divided by m1. So it means that LHS equals to RHS, right? So if you put C at this place, so correct formula is m equals to m naught divided by 1 minus b square divided by c square. Is it clear? So you see how does the dimensional analysis helps you in getting almost correct formula, or here exactly correct formula. This is the real formula we have for basically motion of when a object is moving with a speed compared to a speed of light, then its mass varies in this fashion, which is called the Einstein's theory of special relativity. It is one of the part of Einstein's theory of special relativity, right? So this is the correct formula. So you see how the dimensional analysis helps you in finding the correct formula or putting the C in the right place. Dimensional analysis आपकी किस तरीके से मदद कर रहा है आपको करेक्ट फॉर्मूले को फाइंड करने के लिए. If there were some factors, obviously that were then dimensional analysis would not have been that much helpful. But at least it will make sure that the formula is dimensionally correct, whether it is completely basically factor correct in all the factors or not, right? So this is one simple example. ये एक simple सा example था और जो आपको समझ में आया होगा, ऐसे मुझे पूरी उम्मीद है. Now based on this you should try to solve more number of problems on dimensional analysis, and do comment in my comment section if you have any problem or anything which you didn't understand, and also do like and subscribe, right? So now we'll go to another problem where we will discuss about one dimensional analysis. Means one more example we will take, and that's a beautiful example which came in JEE Advanced, or just at some very time, means very earlier time, like in somewhere in 2000s, when we were in our high school days, right? So let us talk about it. The problem is following. If you recall van der Waals equation, what does it say? So van der Waals equation in its correct form is, so let us write it. The question is, so the van der Waals equation. So if you know it, what is van der Waals equation? Van der Waals equation is an equation in thermodynamics, which we will talk about the correction in ideal gases when they move from the ideal conditions. They move, basically most of the gases show non-ideal behaviors. So it's a correction, it's a corrected equation. So let us write the van der Waals equation. So it says P plus A into n square divided by V square, it's capital V, and V minus, where V minus NB equals to nRT. So this is what we call, so PV equals to nRT is one ideal gas equation, and this part which is an square by V square plus and minus NB are called the van der Waals correction in ideal gases to make them more realistic. So this is more realistic model, right? There are some other models also which came later, but this is more frequently used model, what we call the van der Waals equation of state, right? So in this we want to calculate the dimension of some unknown quantity A and B. Now but first we try to understand what are the known quantities. P is known, which is pressure, V is volume, N is the number of atoms, which is in mole, and R is your constant, the gas constant, universal gas constant is there, and T is the temperature, right? Now dimension, right? So how you can calculate the dimension of this? Now to calculate the dimension, what you will do, that you will use the same law which we use, principle of homogeneity of dimensions, which the quantities having same dimensions can be added or subtracted, which we are using very we used in the last problem also. पिछले problem में भी हमने इस्तेमाल किया, यहाँ भी हम कर रहे हैं, right? तो देखते हैं कि कैसे हम calculate कर सकते हैं. Now so it means that whatever the dimension of P is there, it is the same as the dimension of A n square by B square, right? So just use it. Solution. So P has same dimension as A n square divided by V square. V is volume, remember that. So it has a dimension L cube, and is mole, so mole square. So P is what? P is pressure, it's a tensor. So it is force per unit area. So M L to the power minus 2 divided by L square. So m l to the l minus 1 divided by T2 into the power. This is what we have the pressure, and this is what we have A into mole. If you are taking mole as n, we took it at some places, n square, and this is L to the power 6. Right? Volume is L cube, remember that. It is length multiplied by length multiplied by length, and square is L to the power 6. So just simplify it. So you will get A as m L to the power 5 T to the power minus 2 n to the power minus 2 as the dimension of A. Right? So this, you see how simply you can calculate it. M mass to the power 1, length to the power 5, time to the power minus 2, and mole to the power minus 2, the dimension of A. Now let us go to B. So V is nothing but V minus NB. So dimension of V is same as the dimension of NB. Right? Right? So what is V? V is volume, which is L cube, and N is number of moles multiplied by B. So B gives you L cube n to the power minus 1 as the dimension. Right? So this is the simple dimensional formula we have, right, for A and B in the van der Waals equation of state. So you see how the dimensional analysis can be helpful in solving some of the problems easily, right? So हम डायमेंशनल एनालिसिस का यूज करके बहुत सारे प्रॉब्लम्स को आसानी से सॉल्व कर सकते हैं. एटलीस्ट हम फार्मूले को सही प्रेडिक्ट कर सकते हैं अप टू सर्टेन एक्सटेंट, राइट? तो आप इसे नोट डाउन कर लीजिए, एंड इफ़ यू हैव एनी क्वेरी प्लीज़ राइट इन द कमेंट सेक्शन. If you have some particular problems also, you want to ask anything, you can comment in the comment section. You want some improvement or anything like that, quality of the video or voice or anything, then also you can comment there in the comment section. We will try to improve it, right? हम इसके बारे में हम इसको improve करने की पूरी कोशिश करेंगे. Thank you.